Let's do a little quadratic application. Okay, two trains leave a station at the same time. One heading west, south. Train travelling west travels 20 miles faster. After 2 hours, the trains are 200 kilometers apart. Okay, have a quick read of that. Find the speed of each train. Now, the point behind this is to do a sketch. Okay, so here we go. The train heading west is going faster, so it'll go further than the one going south. But they are 200 kilometers apart after 2 hours. Now, think about this. Distance, okay, remember, distance equals speed times time, rate times time. Okay, so the speed of this, let's say the speed of the slow one, call it R. The time it goes, oh, it's 2 hours, so times by 2, let's call it 2R then, okay, 2R. The speed of the faster train is going 20 miles an hour faster, okay. For how long? Again, for 2 hours. Again, doing speed times time, just putting the time in front. Okay, what I end up with is this. Here it is. Now, once you've got that, this is just Pythagoras' theorem. In other words, this squared plus this squared equals 200 squared. Okay, so all of that squared. Right, now here we go. So here it is. Okay. Now they've done something different. I would do the distributive law. I would do 2r. I would call this 2r plus 40. You know, all this operation. Multiply by the 2, then square it. Now remember, 2r plus 40 times 2r plus 40 is like doing a FOIL. Don't just square the 2r and square the 40. It's like having another one next to it. All right. So you will end up with, when you FOIL this, do the distributive law, you'll end up with this here. Okay. That's just that bit there. We still have to add 2r squared. Remember, all 2r squared, which is 2r times 2r, which is 4r squared, and then 200 squared, which is 40,000. Okay, so that's you doing Pythagoras' theorem. Once you collect everything together, set it equal to 0, you end up with this line here. Okay, now everything divides by 8. Make life simpler. You end up with this. Now after that, it's just a question of whether you can factor this, or you have to use the quadratic equation formula. This will factor even though it's some big numbers. All right, apparently it factors into these two parentheses. So when you solve, you'll end up with negative 80 or 60. Now think about it. You can't have negative speeds. Okay, this is a real life situation. So the speed of the slower train is 60 kilometers an hour, 60 miles an hour, whatever the units are. Okay. Now, if the faster train is going 20 kilometers miles an hour faster, whatever it is, it will actually be going 80. It's not going negative 80 though. So the other train is going 80. Okay. You actually found it over here, but of course it's not negative 80. Right, there you go. That's just you using an example application, quadratic equations. Okay.